Okay, good morning. Today we're going to talk about section 2.7. We do have a quiz on Thursday. It's going to be over section 2.6 only. We'll get to talk about that a little bit on Wednesday and give you guys the quiz on Thursday. So here we go, section 2.7, absolute values. We worked with this a little bit already. Now we're going to kind of formalize and talk about some special things about absolute value. So going on to this, just to make a table of absolute value, first thing I'm going to do is if I make this table and I plot these points, I always start off with 0 as my x. And I put 0 in there, so the absolute value is 0. How far away from 0 is 0? Well, it's 0. I'll put it down right there. And then I always like to go positive. So now I'm looking at the absolute value of 1, which is 1. And then I put 2 in there. The absolute value of 2 is 2. And let's say we go negative 1. The absolute value of negative 1 is 1. The absolute value of negative 2 is, that's negative 2, this is 2. And what happens is this continues. So this is down in here, and this one comes down in here. All right. And as we've already done, we worked with this already. We find out the absolute value is a nice V. Notice that I go over 1, up 1, over 2, up 2, over 3, up 3, over 1, up 1, over 1, up 2, over 1, up 3. It doesn't make any difference if I go left or right, but this is my parent function, so I'm always going in the same particular pattern. Doesn't matter, doesn't change in that regard. So if we talk about that as a parent, now here's what we got. The vertex point. The vertex point is this point right here. The vertex point is when it stops. One part of the V stops and the other part of the V stops, and that's where they meet. So the vertex is point to the V. And then the axis of symmetry. It is the vertical line that splits the V in half. So if I go back here, and let's get a different colored pen going here for you guys. So as I look at this, if I put this dash line right here, it splits it right in half. Okay, so what I do with that is this is the equation x equals 0. Now notice, all that notice is I just put this and set that equals 0. Okay, now the axis of symmetry, and we'll use this in a lot of other types of things. The axis of symmetry goes right down through the vertex. As soon as I find out what the x-coordinate of the vertex is, I know what the axis of symmetry equation is. Okay, it's a vertical line splits, always written as in the equation x equals. It always looks like that. It's always going to be a nice vertical line. So, as far as the transformation, now remember, this is outside. Change my pen color again. This is outside, and it's multiplication, so this is a vertical stretch. This is outside. This is a vertical translation. So that's a slide up and down. And this number right here is on the inside, so that's horizontal. And that's still a translation. Notice it's being added. And remember, anything on the inside is going to be the opposite of what we normally do. There is not horizontal stretch. There isn't anything like that. So that's all we're looking for. Now remember, anything inside of here ends up to be the axis of symmetry. So we'll have to play around with that just a little bit. So if I pull this one out, I need to get rid of that. Let's get to the sorry. So let's say I have y is equal to absolute value x minus 3 plus 2. Okay, so now as I look at this, I know that this is right 3 and down 2. Okay, I know that because right here, that's what this says, that's what this says. Okay, it's not stretched at all. So if I think about those are my translations. Well, hey, you know what? my axis of symmetry, that's going to be x equals 3. Goes right down through this one. My vertex ooh, that was weird. My vertex is 3, 2. All that information I get just by looking at that. Now notice my translation really tells me my vertex. So if I look at this next one, y is equal to absolute value x plus 4 minus 1. Okay, let's do this a little different. The vertex is -4 and -1. Axis symmetry, that's going to be x equals -4. And then I want to talk about my translation. This is left 4 down 1. Now, so if I was thinking about this, 1, 2, 3, 4, down 1, there it is. They go over 1, up 1, over 2, up 2, over 3, up 3, over 1, up 1, over 2, up 2, 3. No stretch, nothing like that. Just nice formula like that. Works out really quick and really smooth. Okay, so once again, just to recap this, my vertex, opposite this number, which is my horizontal shift, and my vertical shift. That's my vertex. Axis symmetry, take this. You could take this and equals 0, x equals -4. You could solve it to figure out what that vertex is, but really it's just going to be what your horizontal shift is. And then this recaps what we've done the last couple of days. So I really think it's easy. You want to find that vertex first. And then I want to decide if it's being stretched or reflected. Now, if it's not being stretched or is not being reflected, then I know it's a 1, 1, 2, 2, 3, 4, or 1, 1, 2, 2, 3, 3. Sorry, it's not 3, 4. And then the axis symmetry, you get third pay. I don't necessarily pay attention too much to that. So that's the way these work. So if I have y is equal to 2x minus 1 plus 1. All right, so plot the vertex. My vertex is at opposite this, 1, 1, 1, 1. Determine if it's being stretched. It is. So it's not growing at 1, 1. It's growing at 1, 2, 2, not 2, but 4. Notice that this is the slope up 2 over 1. Plot these. Right in. If I want to know what my axis symmetry is, it goes right down through there. Now, this thing, get to third point based on that. Well, we got this point right here. Well, if it's axis symmetry, it's 1 away. It's 1 away. This one was right here, 2 away. It's 2 away. Okay. Now, the benefit of this. Well, we can use this a lot of different ways. So let's say I take this particular one, I have to graph it. First of all, it's going to be reflected. I know that the vertex is at 2, 4. And I know it's growing normally, but it's in a reflected way. The thing is, that 2 is kind of different for me. So let's put the vertex down, over 2, up 4 per dot. And it's reflected but not stretched. So 1 all the way down through here. Graph this in. Okay, now, when does this equal 2? All right, so normally we write it as y is equal to this, right? So what I'm saying right here in this problem, y equals 2. Well, that's a horizontal line that goes across this. So if I have that horizontal line that goes across this, where does it hit it? Right there, right there. So that means that for my answer, y would be 0. and y will be 4. So if I wanted an ordered pair, it'd be over 0, whoop, y would not be 0. Over 0 up 2, and this one will be, this is just not right, that's x equals 4. Then it will be over 4 up 2. Those are the 2 points that it hits. You just get a nice visual about this. So if you wanted to graph these things, if you couldn't figure it out, you can always put that in your graphic calculator into decimals, put in the equation, put what it equals to, y is equal to that, go across there and look to see where it does it touch. That's really what I'm looking at. Okay, your assignment is this particular worksheet, and if you just click on that link on your homepage, you'll be able to find that. Okay, start thinking about that quiz that you're going to end up having on Thursday of this week so that you're well prepared for that. Have yourself a good day.